Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. And today we are starting a new unit about rational expressions and equations. So we probably will have 4 sessions. The first one is just pure simplification. Then the next one, we'll see how we multiply and divide rational expressions. And then we'll learn how to add or subtract. As you know, with dealing with fractions, that addition and subtraction are more involved. They require more work than simple multiplication and division. And finally, we'll conclude this unit with solving rational equations. Okay, I hope it would be nice. We'll learn some, not tricks, but some like shortcuts that would help us solve these problems quickly. The first one is very simple, simplification, right? Simplification must be simple. So how do we simplify these rational expressions? As you already know, we should just bring them to the lowest denominator. In other words, we want to simplify both the numerator and the denominator. So when you look at problem number 1, you look first at the numbers. Can I simplify 28 and 35? If you still remember your multiplication table, you will see that 28 and 35, both of them are divisible by 7. So I will divide top and bottom by 7. And then I look at the variables. I only have one variable here, which is x. And the numerator has x cubed, and the denominator has x to the 5th power. Of course, then the lowest common denominator would be x cubed, which I will divide by. So I'm dividing here by 7x cubed, and here by also 7x cubed, because then I divide top and bottom by the same number, except if it's a 0, then I didn't change anything. So what do I get? 28 divided by 7 is 4. X cubed by x cubed is 1. So the numerator is simply 4. 35 by 7 is 5. And x cubed divided by x to the 5th divided by x cubed is x squared. That's how easy it is. Now, what if the numerator and the denominator have multiple terms? Like it's a binomial here. But I still see that 5x and 40, if I look at the numbers 5 and 40, I can factor out. Notice I didn't say I'm going to divide. The reason I divided here is both of them were divisible by 7. But if I look at those numbers, I see that I can factor this as 5 times x plus 8. And I can divide the bottom, or I can factor a 4 out, and that would make it 4 times x plus 8. And now I can divide by x plus 8 top and bottom, and the answer would be 5 over 4. Or if you don't like improper fractions, you can write it as 1 1/4. Okay, when I move to number 3, it's like number 1. 36 and 12, in fact, both of them are divisible by 12. So I'm going to divide by 12. And then I look at the variable, it's y. I have y squared and y, so I divide by y top and bottom. The denominator would be 1, so I don't need really to write it. 36 divided by 12 is 3, and y squared divided by y is y. So I can say 3y over 1, but it really it's not necessary. Now, let's move to the second row. Oh, that's a trinomial. A trinomial may be factored. So I look at that and see, do I have two numbers that when I multiply, I get 20, and when I add, I get 12? Remember what we did before? We said 20 can be 20 and 1, but they add up to 21. 20 is divisible by 2. So if I make it 10 and 2, they add up to 12. Yes, I have that. So I factor the numerator as x plus 2 times x plus 10. The denominator has a 3 as a common, so I factor out the 3 and I get x plus 2. I see that the x plus 2 and the x plus 2 can cancel, and I get x plus 10 over 3. There is no space to rewrite it, but oh, you can write it here, x plus 10 over 3. Okay? Usually when you divide by something like that, it is better to say x doesn't equal -8. Why? And here I can say x doesn't equal 0, but we are not really solving, we are simplifying. Do you see what I'm saying? If x is 0, in fact, the whole expression would make no sense because it would be 0 divided by 0 from the get-go. We are going to look into that later when we solve uh, like rational equations. But for now, it's really, we are simply saying it simplifies to that. Okay, we are not solving. Of course, if x is -2, I cannot say that the answer would be, anyway, it's not an equation, so we don't care about that now. But I want to draw your attention that when we solve equations, and if this whole thing equals something, and I simplify, I have to say x doesn't equal -2. Because if it is, so at the end of the day, when I solve the problem and I get x equals -2, I say, uh-oh, it doesn't work because I divided by x plus 2. So keep that in mind. What we will do usually, I will explain it in more detail when we get to that. I think I have free time today, so maybe I'll do all the 4 videos, but I'm gonna post them on 4 different days. So one tomorrow and then the next 3 after that. Okay, when I go to the second one, I have 6 and 30. I can simplify that as 6 times x plus 5. Usually when in these types of problems, when you see x plus 5, it's like giving you a hint that I can factor one of these factors when I take this trinomial would be x plus 5. You see that two numbers that multiply to 15 and add up to 8, if one of them is 5, the other is 3. So we know that so that would be like a quick thing you have to think about. Maybe you cannot simplify, and maybe that is not one of the factors, but there is a great chance that it will be. So x plus 3 times x plus 5, I can simplify and get my answer as 6 divided by x plus 3. Okay, let's move to the next one. I have numbers 25 and 15. Both of them are divisible by 5. So I'm going to divide top and bottom by 5. A cubed and a to the 8th. So I'm going to divide by a cubed. So 5a cubed. B to the 7 and b cubed. So I'm going to divide also by b cubed. Now, 25 divided by 5 is 5. A cubed divided by a cubed, it vanishes. It's just a to the 0, which is 1. B to the 7, b cubed is b to the 4. -15 over 5 is -3. Notice I prefer to write the negative here. And someone may say, oh, but the negative sign is in the denominator. What? What do you mean? There is no difference between -a over b and a over -b and -a over b. We prefer to write the negative separate before the fraction so it doesn't confuse you, but again, it's not wrong to keep it in the denominator, but you have to understand now when we are dealing with math, these things are like, it's like, I don't know how to say that, but it's like, when you do abbreviations or you do, or even when you talk, when you say, I will go, you can say, I'll go, right? You see, it's the same thing. The negative being down, you can usually write it like that. I know it's a horrible comparison, but okay, forget it. 15 divided by 5 is 3, so I write 3. A to the 8 divided by a cube is a to the 5th, and b cubed by b cubed is 1, so it simplifies to that. Let's go to the next row. Again, I have 5, so I factor 5 and x minus 3. In the denominator, I factor x, and I get x minus 3. So these two would cancel, and you will get 5 over x. Next one, I have numbers, k's, m's, and n's. So let's see what we can factor out. 38 and 24. Only 2, right? The 38 is 2 times 19. Both of them are prime numbers. You cannot simplify the 2. You cannot simplify the 19. So I'm going to divide by 2, top and bottom. Then k squared and k to the 4th. Then k squared is the maximum you can divide by, or the greatest common factor. M squared and m, just m. N and n to the 5th, just n. So now my numerator would be 19, which is 38 divided by 2. K squared and k squared cancel each other. M squared and m leaves me with m. N and n, they cancel each other. The denominator, 24 divided by 2 is 12. K to the 4th over k squared is k squared. M and m cancel. N to the 5th and n is n to the 4th. See, it's very simple. Last one here. I can factor a 7, and that leaves me with x minus 2. I can factor an x, and that leaves me with x minus 2. So, simplifying, I get 7 over x. Let's move to the next row. I have 16 and 8. The common factor is 8. So I'm going to divide by 8. X squared and x cubed, it's x squared. Y to the 5th, y squared is y squared. Z and z squared, it's z. So when I divide negative 16 over 8, I get negative 2. X squared by x squared, they cancel each other. Y to the 5th, y squared is y cubed. Z and z, they cancel each other. 8 over 8 is 1. We don't write 1. It's not wrong, but it doesn't make sense. X cubed and x squared, that's x. Y squared and y squared, nothing. Z squared and z is z. Number 11. Both can be factored because both are trinomial. We don't know if they can be factored, but makes sense to see if I have two numbers that multiply to 8 and add up to negative 6, meaning both of them should be negative. Yes, 2 and 4. So when I go down, I see that x squared plus 2x minus 24, I need two numbers also that multiply to negative 24. So meaning one is positive and one is negative. The larger is positive, and these two numbers are 6 and 4. 6 and negative 4. So x plus 6, x minus 4, and the x minus 4 simplifies, and you get x minus 2 over x plus 6. Last one in this row, I have a 9 common factor, so x plus 1. And this one, I can see the two numbers that multiply to 7 and add up to 8 must be 7 and 1. So x plus 7, x plus 1, they simplify, and you get the answer as 9 over x plus 7. Finally, I go to the last row. Should I have another color? I think we can restart. Okay, the numerator. I have two numbers that multiply to negative 28, and the difference is 3 positive. So I have x plus and x minus. The two numbers, of course, are 7 and 4, because 7 times 4 is 28, and 7 minus 4 is 3. And since this is positive, then the larger of the two numbers is positive. The denominator is also, one of them is positive and the other is negative, but this time the larger is negative. And 8 is 4 times 2, right? Because 4 minus 2 is 2. So, but the bigger is 4 and the smaller is 2. And then I can simplify by dividing and get the answer as x plus 7 over x plus 2. Here you have two numbers that multiply to 6 and add up to negative 7. So both of them are negative, and they are 6 and 1, right? That's the only way you get two numbers to multiply to 6 and add up to negative 7. And the denominator has x minus 6. I simplify by doing that, and you get the answer is x minus 1 over x. Okay, last one. We can divide top and bottom. Notice it's a monomial. It's only one term. So that's why every time you have a monomial like that, you can simply go ahead and divide, simplifying, instead of factoring. Okay? So here I'm going to divide top and bottom. 36 and 42, what do you get? Yeah, 36 is 6 times 6, and 42 is 6 times 7. So I can divide top and bottom by 6, right? Because when I divide, I get 6 and 7. Oh, yeah. Oh, my God. I did it to myself. They cannot be, they don't have anything in common. So that's why you like it, right? I have a to the fifth and a to the seventh. So I divide a to the fifth, top and bottom. B square and b square. So I divide by b square and get done with it. I won't have any b's. That doesn't sting, right? C to the 6 and c square is c square. So at the end of the day, 36 divided by 6 is 6. A to the fifth divided by a to the fifth is 1. B squared by b squared is 1. C to the 6 over c squared is c to the 4. The denominator, 42 over 6 is 7. A squared, a to the 7 over a to the fifth is a squared. B squared and b squared cancel. C squared and c squared cancel. And I'm done. Okay? I know that this was an easy one, a very quick. I know we did all 15 of them, but they really don't take long if you know what you're doing. So be careful. If it's more than one term, you need to factor top and bottom. If it's just a monomial, just simplify it. Okay? Best of luck and see you soon. Well, I'll see you tomorrow when we do the second sheet or worksheet about multiplication and division, which should be very similar and easy to do. Thanks for your time. Hope to see you soon. Have a great day. Bye.